In time series analysis, validation methods are crucial for evaluating the performance and reliability of predictive models. These methods help in understanding how well a model can generalize to new data, which is essential for making accurate forecasts. Here is a comprehensive look at some common validation techniques used in time series analysis, their concepts, and applications. Train test split. This is the most basic validation method. The data set is divided into two parts: the training set and the test set. The model is trained on the training set and validated on the unseen test set to evaluate its predictive performance. However, this method may not be sufficient for time series data, as it does not account for temporal dependencies. Cross-validation. Unlike simple train test splits, cross-validation involves multiple splits of the data. Techniques like k-fold cross-validation are adapted for time series by ensuring that the data's temporal order is respected. Instead of shuffling data, successive training and validation sets maintain time order. This method offers a better understanding of the model's variance and bias, but can be computationally intensive. Walk-forward validation. Due to the temporal nature of time series data, walk-forward validation is often used. Here, the training data set is incrementally expanded, and forecasts are made sequentially. This method simulates a real-life scenario where new data points become available constantly. It allows assessing how models update with new information. Time series split. Cross-validation. This method is specifically designed for time series data. Data is split into several contiguous temporal folds. Each fold uses a portion of the data as the training set and tests the rest. This maintains the time order and gives a robust estimate of model performance. Time series split cross-validation is invaluable when data order cannot be disrupted. Rolling forecast origin. In this technique, a fixed-size test set moves across time, while the training data set expands. Each step involves re-evaluating and refitting the model. This method helps in understanding model stability and adaptability over time, crucial for dynamic environments. Backtesting. Commonly used in finance, backtesting involves applying a model to historical data to validate its predictive ability before using it in live scenarios. It assesses the strategy's strength against historical events and provides valuable insights for improvement. Holdout method. Similar to the train test split, but more strategically defined, this involves holding a particular segment of data for testing while using the rest for training. This is useful when a specific past event needs exploration to test model generalization. Each method has its strengths and limitations, and often, a combination of these techniques is employed for robust model validation. Selecting the right validation method depends on the data characteristics, the specific requirements of the modeling task, and the potential applications of the forecasts. Understanding these validation methodologies enables better model development and enhances the reliability and applicability of predictions in various time series contexts.